So friends, in my last session we had stopped at inverse of the matrix and we had seen this particular formula to calculate inverse of the matrix, and now in this session we will try to understand what is this adjoint of the matrix. So this is our next topic of discussion. Adjoint of the matrix, also called as adjugate of a matrix. So here the one thing that you need to keep in mind is whenever we make use of the word adjoint, it is nothing but our classical adjugate. So both adjugate and adjoint is having the same meaning. So here we are referring to this particular word as adjoint and not adjugate. Both are having the same meaning. So the first point, the adjoint of a matrix is defined as transpose of the cofactor matrix. So here you need to remember I am introducing two more concepts. When we wanted to calculate inverse of a matrix, we saw it can be calculated with this particular formula, 1 divided by determinant into adjoint of A. So we have understood what is inverse of the matrix, still we have not understood how to calculate inverse. Then I came up with this particular adjoint of the matrix. So in order to understand what do you mean by adjoint of a matrix, here we are bringing the concept of cofactor matrix and transpose of matrix. So see the way we are dealing. So first I explained to you all what is determinant of the matrix. Second, in this session I have explained to you all in the previous session what is inverse of a matrix. Now we have come to the third part, understanding what is adjoint of the matrix, and to understand adjoint of the matrix we need to know what is the cofactor of the matrix, and then we need to know what is the concept of transpose. So these are the 5 important things that we are dealing in matrices. So once you are dealt with this thing, maximum things become more simpler. So what is cofactor matrix? A cofactor is a number that you will get when you remove the column and row of a value in a matrix. Remove the column and row of a value. What is this value? Let me say of a particular element in a matrix. So the cofactor of an element of a square matrix. So let me say 1, 2, 3, 4, 5, 6, 7, 8, 9. So if this is a 3 by 3 matrix, it means it's a square matrix, and we are having 9 elements in this thing on different positions based on their rows and columns. So the cofactor of an element of a square matrix is, so let us say if this is an element of a square matrix, what is its cofactor? Its cofactor is the minor of the element with a proper sign. Please friends, keep in mind, minor of the element with its proper sign. So here I am speaking about sign. It may be plus or minus. This is first part of what? Of the minor. And already we have seen what is minor when we are speaking about determinants. You can revisit the session on determinants to understand minor. So this is what is cofactor matrix. So cofactor matrix is an element with its minor with a proper sign. Now this will become more clear to you when I come up with an example. So let me say this is a cofactor matrix. How to find it out? There is a matrix A, and in this matrix A, in the previous session I told you how to solve the determinant. So determinant of A is the element multiplied by its minor. So this is the element multiplied by its minor minus this is the element 6 multiplied by its minor, that is 2871. And similarly, when I speak about this particular element, plus 5, remove this thing and remove this, what remains is 2179. So this is with regard to finding out determinants, but we are not interested in determinants because already we have done it. We are more interested in this minus. So every element has its minor. Keep in mind, every element has its minor. So next is this shaded area, I call them as minors, and I will take it to the next part. So here this is what minors of the elements. So what are the elements? Here we have taken the elements of row 1. Similarly, we need to take elements of all the rows, or you can say all the columns. So I will come up here. 1891 is the minor of element 3. Similarly, 2871 is the minor of element 6. 2179 is the element of, so is the minor of element 5. Now if you want to know what is the minor of element 2, what I will do, I will remove this particular row and this particular common. So what is left with me is 6591. So the minor of element 2 is 6591. Similarly, if I want to know what is the minor of this particular element, I will remove this row and this column, and what is left is 3571. And lastly, if I want to know what is the minor of element 8, I will remove this particular column and this particular row. So what is left is 3679. And now coming to the final row, if I want to know what is the minor of element 7, I will remove this row and this column. So what is left is 6518. Similarly, minor of element 9, what is left is 3528. And lastly, minor of element 1, I will take out this column and this row, what is left is 3621. So friends, this is what the minors of all the elements in the matrix, and I had told it should have a proper sign. So here it has this particular sign. Now you may ask me from where this particular signs came or why it is like this. So to find out the signs, friends, with regard to cofactors, there is a simple formula: -1 raised to I plus j into the minor. Now what is this I plus j? So this is C1, C2, C3, R1, R2, R3. So this 1, this is what is I by j matrix. So this is 3 by 3 matrix. So this 1, 1, 2, 2, 3, 3 is what is this I by I plus j. Now when I am speaking about minor of 3, so when I am speaking about minor of 3, so -1 raised to, what is I and j? 1 plus 1, 1 plus 1 into its minor, minor of ij. So -1 square into its minor ij. So -1 square is -1 multiplied by -1. So what we get is +1. So this plus has come here. Similarly, I'll take one more example. Let me say, what is the sign that comes for this particular element? So here -1 raised to I plus j into its minor. Now we know the minor of 6 is 2871. This is the minor of 6. Now minus 1 raised to 1 plus 2, 1 plus 2, this is minus 1 raised to 3. So, matlab minus 1 into minus 1 into minus 1, 3 times minus 1 cube. So, minus into minus plus 1 multiplied by minus 1. So, what we get is minus plus 1 into minus 1 is minus 1. So, this minus sign has come here. So, similarly friends, if you want to find out with regard to, let us say, this particular element 1. So, what it happens, minus 1 raised to second row second column 2 plus 2 into its minor. So, minus 1 raised to 4. So, you know minus 1 into minus 1 into minus 1 into minus 1 will give us plus 1. So, this is the reason this plus is here. So, I hope you have understood how these signs have come. So, with this friends, we will go ahead, and this particular thing, when I put it in the brackets, it becomes our cofactor matrix. So, this is our cofactor matrix which we have got. This is our cofactor matrix which I called it as C. So, with its sign. Now, what I am going to do is I am going to solve this thing. So, as you know, when we are dealing with determinants, how to solve this thing? 1 multiplied by 1 minus 8 into 9. So, what I am going to get is 1 minus 72. So, 1 minus 72 is minus 71. Similarly, this 2 into 1 minus 8 into 7. So, this becomes 2 minus 56. So, it becomes minus 54. And here 2 into 9 minus 1 into 7. So, 2 into 9 is 18 minus 7. So, what you are getting is plus 11. Similarly, when I solve for this particular minor, I get minus 39. For this, I get minus 32, and for this, I get minus 15. For this minor, I get 43 as a value, and one more I will solve it and show it to you. This is 8 multiplied by 3 minus 5 multiplied by 2. So, 8 multiplied by 3 is 24 minus 10. So, this is 14. And similarly, with regard to this thing, 3 into 1 minus 6 into 2. So, 3 minus 12, this is going to give me minus 9. So, this is how we have calculated the values of all the minors. And now, the next part is I need to sort out this. Here it is plus and here it is minus. Here it is minus and here it is plus. So, plus into minus is minus 71, minus into minus is plus 54. This is plus as usual. Here also it is plus. Here minus into minus, it becomes plus 39, plus into minus, minus 32, minus into minus, plus 15, and here it is plus 43 as it is. Here it is minus 14 as it is. Minus into plus, minus, plus into minus, here it is minus 9. So, this is how we have got our cofactor matrix. Now, we will try to understand transpose of the matrix. The matrix that is obtained by interchanging its rows with the column is called as transpose. For example, if I say A is a matrix as 1, 2, 3, 4, then when we transpose it, it is nothing but this particular column, it becomes the row 1, 3, and this particular column becomes the row 2, 4. So this is what is transposing, when you are reversing the rows and columns, and this is denoted by a raised to t, that is at. So if this is our matrix A 3 6 5 2 1 8 7 9 1, then the transpose of that is this particular thing, this particular column has become our row, and column 2 has become our row 2, 6 1 9 6 1 9, and similarly 5 8 1 column becomes here 5 8 1 row. So this is what is transpose of the matrix. So now we have come to the last part, transpose of cofactor matrix. So we are having our cofactor matrix, now we need to transpose it. So we need to have the transposed cofactor matrix. Now what has to be done over here? All the rows needs to be interchanged as columns. So you can see the first row minus 71, sorry, first column minus 71 39 43, this becomes the first row. Similarly the second column, it becomes our second row, and lastly our third column becomes our third row, and this is what is called as adjoint of the matrix. So in my beginning slide I told you what is adjoint. Adjoint of matrix A is transpose of cofactor matrix, and here you saw we understood what is cofactor matrix and we understood what is transpose of a matrix. So once we transpose the cofactor matrix, what we are going to get is adjoint of the matrix, and this adjoint of the matrix is helpful for us to calculate inverse of the matrix. So a quick recap with regard to inverse of a matrix. So this is where we started. What is this? A raised to minus 1, it is inverse of the matrix. How do we calculate inverse of the matrix? To calculate inverse of the matrix, we need to know determinant of the matrix. So how to calculate determinant of the matrix? We need to row 1 elements multiplied by its minus. So this is what you can just see the previous slides. Row 1 elements is multiplied by its minus, you get determinant of the matrix. Then to calculate adjoint of A, that is adjoint of the matrix A, what we need to know? We need to know transpose of the cofactor matrix. And here how to find out the cofactor matrix? Here we need to know minors of all the elements. So these are the different steps. So quickly we understood determinants. It may be of 2 by 2 matrix how to calculate, or 3 by 3 matrix how to calculate. Then we understood what is inverse of a matrix, and to calculate inverse of the matrix we need to know the determinants and we need to know the adjoint. Here one condition is that the determinant should not be equal to 0, because here if determinant is equal to 0, that is 1 upon determinant into adjoint of A. If determinant is 0, 1 upon 0 is undetermined. So we cannot find inverse of the matrix if determinant is 0. So this is one condition. To calculate adjoint of the matrix, we need to know cofactor of the matrix and cofactor matrix and transpose of the matrix. So as I told you, first we understood determinants, then we understood what is inverse, then we understood what is adjoint, then we understood what is cofactor and transpose. So these 5 particular important concepts will help us to solve most of the problems that comes under matrices. So with this I'll stop the session over here. In my next session I'll take up an example where we'll be using linear equations to find out the variables using inverse of the matrix. So till then, be with me and Keep on enjoying the sessions.